Before we place AI anywhere, here is what decides more than the model you pick. Especially in manufacturing, the biggest factor in any AI project? The state of your data. Get this wrong, and even the best AI stays limited. It simply will not have much it can actually do. Two things matter. First, is your data accessible? Can the AI reach it, to use it, or to train on it? And second, is it contextualized? Does each value carry its meaning, or is it just a bare number? When both are true, AI has something real to reason over. When they are not, it is guessing over noise. So this is the real first step before any clever model. And one proven way to get your data into that shape starts with a unified namespace, something you build on purpose, not a default you inherit. We will take it a piece at a time, because right now your plant is streaming thousands of tags and your AI still cannot really use them. Let us see why. Take one tag, TT402 1 equals 47.2. 47.2. What? Degrees? Which machine? Which batch? On its own, it is a value, not knowledge. And there are actually two problems hiding here. One, the data is scattered. Sensors, the PLC, the historian, the database that archives your process readings, the ERP, each in its own format, its own island. Two, even if you gather it, a number still does not carry its meaning. Access and meaning, you need both, and raw plant data gives you neither. So, first problem first, access. This is what a unified namespace does. Instead of data trapped in separate systems, the UNS gives you a single, real-time structured place where all of it lives, every sensor, every system, one live source of truth. Now, when the AI needs something, there is one place to look, and it is current. That solves access. But notice, it does not yet solve meaning. Everything is in one place. It is still a pile of numbers. Now the second problem, meaning. This is where a knowledge graph comes in. You connect the data following an agreed model of what things are and how they relate. So instead of a loose number, this moisture reading belongs to the dryer. The dryer is on line 3. Line 3 is running batch A12 for that customer's order. Suddenly the number has a story around it. That web of connections is the knowledge graph, and it is what lets the AI reason with context instead of guessing from an isolated value. Access codes the data into one place, meaning turns it into something the AI can actually think with. So that is the foundation. In one picture, a unified namespace for access, a knowledge graph for meaning, and together they are what make optimization, machine learning, and AI actually trustworthy. Without it, even the best model is guessing over a pile of numbers. And here is the honest part. This foundation does not appear by default. It is deliberately engineered, designed and built on purpose. That is real work up front, and it is exactly the work that pays off, because everything above it depends on it. Next, we will see the first thing you can build on it, grounding the model in your own data with RAG. You have already seen the cure. Hand the assistant the current SOP and 14 becomes 12. What you have not seen is how that handing happens automatically, at scale, for every question anyone asks. That technique has a name, Retrieval Augmented Generation, or RAG. Those three letters sound like jargon, so ignore them and watch what RAG actually does. Before the model answers, you look up the relevant material from your own data and hand it to the model to read. Then it answers from what is in front of it instead of from whatever sounds likely. Here is the way to remember it. The model's training is its static memory. Everything it learned once, now fixed in place. RAG is its dynamic memory, the fresh, relevant notes you put on its desk for this question. And it can only use those notes if you give them to it. So let us rerun that question and watch the step that is new, the retrieval. Before it answers, the assistant searches your data and finds the current SOP on its own, SOP 014. Revision C, it reads that and answers 12 correctly, and it can even tell you where it got it. Same model that was confidently wrong a few minutes ago. Nothing about the model changed. Finding the right SOP just became automatic. That is RAG, and that is a direct fix for the hallucination problem we were worried about. But here is the plant-specific catch, and it matters. What you look up from makes or breaks it. If RAG just searches a pile of loose documents, it does fine on vague questions and surprisingly badly on precise ones, the exact plant questions you care about, like a spec, a KPI, or a forecast, where loose document search can miss almost entirely. Ground that same lookup on the knowledge graph we built earlier, the connected structured data, and in benchmarks, accuracy on those questions climbs sharply. Same technique, completely different reliability, so in a plant, RAG should ground on the graph, not a folder full of PDFs. So RAG in plain terms, hands the model your own data to read before it answers, and in a plant, ground that on the knowledge graph, not loose files. Do that, and the confidently wrong problem we saw earlier largely goes away. The model stops guessing and starts citing. That is the first thing we built on the foundation, but so far it can only answer. Letting it act is the next step. So the assistant answers correctly now, but answering is not doing. Right now, it can tell you how you would reorder seed. It cannot actually reorder it. So here is the next step. What if it could check the stock, pull the recent usage, and fill out the draft order for you? To go from talking to doing takes 3 new pieces. Let us meet them. Piece 1, the agent. An agent is a language model that can decide on the steps of a task and use tools to carry them out, not just produce text. Give a plain chatbot a job and it describes it. Give an agent the same job and it works through it. Figure out the first step, use a tool to do it, look at the result, take the next step. That loop, decide, act, check, repeat, is what turns a talker into a doer. The key word is tools. An agent is only as capable as the things you let it reach. Piece 2, how the agent actually reaches those tools. That is MCP, the Model Context Protocol. Think of it as a tool the agent uses to reach your systems. One standard connector. The easiest way to picture it, it is the USB-C port for AI. Without it, every connection to every system is its own custom, fragile wiring job, slow to build and slow to change. With it, there is one agreed standard plug, so the agent can connect to your ERP, your historian, your systems through the same consistent interface. MCP is what turns letting it act from a tangle of one-off integrations into something standard and repeatable. Piece 3, package know-how. This is a specific procedure you save once and the agent loads it when it needs it. Take the reorder procedure on screen. It bundles the steps and the rules. Check current stock, pull recent usage, apply the minimum order, and lead time rules draft the order. Instead of hoping the agent figures out your process from scratch, you hand it the proven procedure. It is how you give an agent your way of doing things reliably, one task at a time. Now, watch the 3 work together. You ask the agent to reorder seed. It loads the reorder procedure for the know-how, reaches through MCP to the historian for recent usage and the ERP for current stock, and puts together a draft purchase order in seconds. That is genuinely powerful. It did not just tell you how, it did the work. And it only works this smoothly because the agent, the saved procedure, and the MCP connection were engineered to fit together. This is not luck, it is setup. But notice what just changed. It is no longer only answering, it is acting in your systems. And the moment AI can act, the stakes go up, which is exactly why the very next thing we add is the guardrails. The agent just drafted a purchase order. One question decides everything now. Should it be allowed to send it on its own? How you answer that, action by action, is what guardrails are. Two of them do most of the work. You already keep a person in the loop for its answers. The moment it can act, the same rule gets teeth. It drafts the order, a person commits it. That reorder does not get placed, it waits for someone to check it and approve it. Approve, and it goes. Reject, and nothing happens. It sounds simple, and it is, but it means the worst a wrong draft can do is waste a minute of your attention. The AI does the work, and a person keeps the authority, and builds safety into the receiving end too. The system that takes that order should have its own checks and limits by design. That is a backstop though, never an excuse to skip the person's review. You know the firm rule of the control loop. The guardrail behind it is a dial, not a switch. The closer a job sits to control and safety, the shorter the leash. Drafting a reorder? Fine, it can act with approval, but the begging line, the actual control loop, there, the AI only advises. It never touches the equipment. Same assistant, very different leash depending on where it is working. Far from the sharp end, it can do more. Right at control, the loop stays fixed and predictable, and the assistant stays outside it, advising. So, two guardrails, both scaling with the stakes. A person approves before AI acts, and the nearer a job is to control and safety, the more AI only advises. Notice what these really are. Not a brake on AI, but the thing that lets you say yes to it acting at all. Pieces, then guardrails. One decision left, and there is a simple map for it. You have now got the pieces, grounding the model, letting it act, and the guardrails that keep acting safe. So the last practical question, should AI run a job, adjust it, or just explain it? One simple map answers that for any job on your floor. It is the map everything here has been building toward. Sort any use into one of three levels. At the bottom, operational, real-time execution and control. It has to be deterministic and guaranteed. So classical automation and machine learning run it, and generative AI is advisory only, never on the loop. In the middle, adaptive, adjusting and weighing trade-offs. Machine learning ranks the options, and generative AI explains them in plain language. At the top, analytical, insight and understanding. Machine learning predicts and spots patterns, and generative AI explains them, anchored to your data. Three levels, that is the whole map. Now, watch how fast it sorts real work. The bagging line control, that is operational. It must be exact and real-time, so it stays deterministic, and the assistant can advise the operator but never touches it. A rush order comes in and you need to reshuffle the line. That is adaptive. Machine learning ranks the feasible options, generative AI explains the trade-offs a person picks. The shift handover, that is analytical. Machine learning flags what drifted, generative AI writes it up in plain language. Same plant, three jobs, three levels, and each one lands somewhere obvious once you ask the question. And notice the two rules running straight down the ladder, the same two that have run under everything so far. First, at every level, machine learning does the math, and generative AI does the meaning. The split never changes, only the mix does. Second, the closer a job is to real-time control, the more AI only advises, and the more a person and the automation stay in charge. Put those together and placement becomes automatic. Tell me the job, and the level tells you the model, the role, and the guardrail. So that is the placement rule you carry away. Three levels, operational, adaptive, analytical, and the right kind of AI in the right role falls out of where the job lands. One honest closing point though, none of what we have covered, The data foundation, RAG, agents, the guardrails, this placement, is plug and play. Each one is architecture and engineering set up on purpose. That is real work up front. But it is exactly the work that makes AI trustworthy on the floor, and it pays off across the life of the operation. Next, the practical questions. Where should all this actually run, and what really pays off?